Hello students, this is lesson U3AO2B. By the end of the lesson, you should be able to say I can use SAS to prove triangle congruence and CPCTC to prove parts of triangles congruent. Alright, so in this lesson, I'm going to introduce the second theorem for proving triangles congruent. And the second theorem is, as the target suggests, it's SAS. So SAS is an acronym. Can you guess what it stands for? If you're thinking side angle side, then you're absolutely right. So let's just observe closely here at what the situation is. We can see that AB here is congruent to side WX. And we also recognize that angle B is congruent to angle X. And then side length BC is congruent to side length XY. The way in which we read this, it's side angle side, because the angle, if you noticed, okay, it's quote-unquote sandwiched in between the two sides. So, of course, the word sandwich is not a mathematical term, okay? A more appropriate technical term is to refer to that angle as being an included angle. So whenever you hear of the term an included angle, this implies that the angle is formed by the elements that joins it together, okay? So we have two sides here that come together and it forms the side, okay? Yeah, so the second thing that we're going to be using in this lesson is the this theorem that we had used in the previous lesson, which was, again, an acronym, CPCTC, which stood for, one more time, corresponding parts of congruent triangles are congruent. Which simply just says, if we know two triangles are congruent, then all the varying corresponding parts should also be congruent. All the corresponding sides, all the corresponding angles, all the corresponding everything, okay, will be the same. Alright, so let's take a look. Right now, you're given two triangles, okay? And in the two triangles, you're also told certain things are the same. And you are not told certain things, and you are also not told certain things are congruent either. Like, for instance, you don't know whether angle L is the same as angle A or angle B. But you are told that angle N is congruent to angle C, and you are told that those corresponding sides are the same. So those are technically your givens. So what I'm going to do, and I want you to do the same, pause the video, see if you can find out anything else that will be congruent based on the information that's given. All right. So I know that MN is congruent to side length AC. I also recognize that LN is congruent to side length BC. And I also recognize that angle N is congruent to angle C. So what we have here, okay, and actually I'm going to reverse the order in which I write. Actually, I'm not going to reverse it. So here we have given, and these two other statements here are also givens. So what we can say, okay, immediately based on this, is that triangle LMN must be congruent to triangle ABC. And the reason for this is we have side angle side. Now it is important for you to see here, okay, these three lines, okay, that I had written down, it was purposeful, okay, if you notice, this is a side, this is a side, and this is an angle, right? SSA is not the same as side angle side. The way in which we read the given information over here, okay, in no particular order at all, okay, we can recognize that the two sides, the two sides in lines 1 and 2 will form the angle stated in line 3. So it is actually implied that the reader of this proof should recognize that line 3 there is an angle, and it is the included angle. All right, so one more time, there's no SSA. You don't read this as SSA, rather you read this as SAS. Okay, so now that we have this understanding that this is SAS, what we can say as a consequence of this, okay, recognizing that the two triangles are indeed the same, we now know that all the corresponding parts of congruent triangles therefore must be congruent. So therefore angle L will be the same as angle A. Angle M must be the same as angle B. And lastly, angle N must be the same as angle C. And the reason for all of these is CP-CTC. All of the corresponding parts of congruent triangles must be congruent. All right, let's take a look at the next example. And I encourage you again to pause the video and to see if you can figure out these things on your own. Now, I recognize immediately that from statement number, that one of the first statements here, okay, that I should write down is side length AC is congruent to side length DC. The second statement that I immediately recognize based on the given information is that EC is congruent to segment BC. And the third thing, well, actually, there is no third thing. Those are the only two items here. Oh, actually, no, I take that back. It says that segment AD, okay, and segment BE, they intersect at C. Okay, so this is all just to let you know that segment ACD, okay, that points A, C, and D, they are all points that are collinear. Same thing with all the points that are E, C, and B. Those are all points that are collinear. Those two line segments intersect at point C. All of these information here are part of the givens. All right, so let's take a look at line number 4. All right, so what can we conclude based on this information here? I immediately can see that angle ACB must be congruent to angle DCE. And the reason, what's the reason for this? Well, I recognize that vertical angles must be congruent. So these are vertical angles. All right, so as a result of this, okay, the fifth line that the next logical statement that I can conclude based on this is, now I have a side, I have an angle, and I have a side. I can immediately say that triangle ABC is congruent to triangle DEC. Okay? All right, so, and this is true because of side, angle, side. So those two triangles are going to be the same. Wonderful. What else can we say are going to be congruent as a result of this? Immediately, I recognize that angle A will be congruent to angle D. And I also recognize that angle B must be congruent to angle E. I also recognize that side length AB must be congruent to side length DE. So these three facts are true based on corresponding parts of congruent triangles are congruent. Actually, upon closer inspection, no, I take that back. Yeah. So there's actually an eighth thing that I forgot to mention here. LM in this example should be congruent to side length AB. I forgot to indicate that in this last proof. And being that I am speaking to myself, sometimes it's hard to catch mistakes that I make. All right, so anyway, so those are the two problems that we just went over where we applied SAS. Let's take a look at the last problem here. All right, so in this diagram, and again, I encourage you to pause the video to see if you can figure things out. Are there any parts of this diagram that we can figure out? Are there any things that we can say are going to be congruent, okay? All right, So hopefully you had some time to think about this. I'm just going to write down all the given information. We know that ML is congruent to SL. I know immediately that EL is congruent to IL. And I know that MS and IE intersect at point L. And the reason for this is these are all information that's given in the problem. It's not anything that I've made up. Or actually, it's not anything that, the person that's trying to solve the problem, has made up or concluded. It's what's provided for the person that's trying to solve this riddle here. All right, so let's take a look. Are there any conclusions that we can draw as a result of this? There's actually a lot of conclusions that you can draw. And that is, we recognize immediately that angle MLI is congruent to angle SLE. And similarly, we also recognize that angle MLE is congruent to angle SLI. And the reason for this is because we recognize that vertical angles are congruent. So both of those are true, okay, for vertical angles are congruent. So now if I take a look at the information that I have here, okay, I immediately see that ML congruent to SL, okay, this is a pair of sides that I recognize are congruent. This is an angle that I recognize as congruent. And this is another side that I recognize as congruent. So there's actually going to be two pairs of triangles, okay, that I can say are going to be congruent. So let's write down those observations here. So based on just those red checks that I've made so far, if I take a look at side length ML and side length SL and EL and IL, okay, and then an angle MLI to SLE, I immediately recognize that I have triangle MLI is congruent to triangle SLE. This is one pair of triangle that I can say are going to be congruent based on SAS. Similarly, okay, now I'm going to use a different set of check marks here. I can also say that I have, and this time I'm going to use purple here, okay, I'm going to say that ML, that's a side, and then I have MLE congruent to SLI, that's an angle, and I have another side. I have yet another triangle that I can say are going to be congruent. So I can say that triangle MLE is going to be congruent to triangle SLI. And this is, again, true because of SAS. All right, so I have so many things that I can actually call congruent as a result of this. And you know what? Just because I just thought of this, I am going to pull this down 3 lines down. Okay? And why am I doing that? Well, that's because I want to describe all the corresponding parts that are going to be congruent between the two triangles mentioned in line 6. Okay, so what are all the corresponding parts there? So let's just take a look. MLI, okay, I immediately know that MI, side length MI, will be congruent to side length SE. I also immediately recognize that angle MIL will be congruent to angle SEL. And I also know that angle IML will be congruent to angle ESL. And the reason for all this is because of corresponding parts of congruent triangles are congruent. All right. Similarly, okay, I can describe all the different elements that are corresponding and that are congruent, okay? So what are all of these parts now? So immediately I can tell that it's going to be ME is congruent to SI. I also recognize that LME, angle LME, will be congruent to angle LIS. And I also know that LEM will be congruent to angle LIS. And this is because of CPCTC. And there you have it.